Okay, so what is reactivity? And so really, if you look at the word that answers in there, and I kind of caps it for you, and it's how an atom's going to act. So reactivity is caused by valence electrons, and those valence electrons are going to determine how reactive an atom will be. So we have some atoms like potassium who are going to react explosively. And then we have some atoms that are not going to have the same reaction. It might have a slightly less reaction, or you might have atoms that don't react at all. So remember, react is just how an atom's going to act. Some valence electrons cause an atom to bond. So reactivity could also be bonding, making a compound. You guys learned about compounds in the 6th grade. And so, for example, you might have two atoms that decide to share a valence electron. And so when they're sharing electrons, they're going to make that compound. So for example, H2O, which you guys learned about again in the 6th grade, is hydrogen and oxygen. So they're all sharing, they've all bonded using that oxygen atom, using those those electrons of valence electrons. Those oxygen valence electrons are all sharing them. Atoms want to be stable or have a full shell. And so the examples here are like helium, it's full. Neon, it's full. Argon, if we look at the last shell, it's full. So atoms, you have like atoms that are not going to react because they have a full shell, but that's what they want. Okay, so reactivity is just how an atom's going to act, and an atom's going to behave a certain way until it gets its full shell. All right. In the next slide, or you have a next slide where you're going to watch a video and put in notes. I'm not going to go over that, but I do want to go over this chart. So you have a reactivity reference chart. And so here in group 1, these are our most reactive metals. So reactivity increases from right to left for metals. So the most reactive metals are in group 1. Non-metals, okay? So group 17 is going to be our most reactive non-metals, okay? And that's really important. So from left to right, reactivity increases. And again, that's when looking at non-metals. Group 18 are our non-reactive or our stable atoms. And it's because they're all full. So they cannot create bonds. They're going to keep their electrons. They're not going to share them with anybody. And so really, again, the goal is for all atoms to have a full shell. Okay, all atoms want a full shell. So they want to have 8 valence electrons, like group 18. Okay. So again, in this video, or in these notes, you're going to go and you're going to watch the video, you're going to answer the question, and then you're just going to add, you're just going to fill this area in. So for example, here we have, there's 1 valence electron, so we know that's in group 1. So you're just going to go and put those patterns in. So here, there's 1, 2 valence electrons. So we know that group number 2 has 2 valence electrons. And VE is just valence electrons, so you don't have to write the whole thing. Here we have 1, 2, 3. So I'm going to put group number 13 has 3 valence electrons. Okay. So you're going to do the rest on your own. So you're going to answer the questions. This question here says, what valence electron numbers are atoms looking for? So again, what do they want? How many do they want? What is their goal? You're going to define reactivity. So what does that mean? You're going to give me the definition of valence electrons. And then valence electrons determines what. And all this information can be gathered from this video here. If you have any questions, please reach out. Thanks, guys.